Alright, this is part 2 of my exponent rules video. You should absolutely watch part 1 first to get the basic exponent rules down. So I'm going to assume that you have watched that already and that you are ready to continue with some more challenging examples. So let's go through and we'll just kind of work through each one. I'll teach you some of the basic advanced rules, or what I perceive to be the advanced rules, and then we'll do like 6 or 7 examples. So here we go. I've got x to a fraction exponent. And we saw this in the last video, so I'm going to go a little bit fast through this one. But it's basically that fraction turns into kind of like a little formula. And if you know this little rule, this little formula, then you've got it. The denominator of the fraction turns into this index right here. So it tells you what kind of root you're taking. In this case, it's a square root. The numerator of the fraction goes inside and gets attached to the base, which is the radicand. And generally we don't write the index of 2 right there. If it's missing, we assume it's a 2, and it's called a square root. And we can turn this one back into exponential form. So you write your base, and this is your index, so that's going to be your denominator. So this one would be 4/3. So it's helpful to kind of be able to go back and forth from radical form to exponential form. Now for my class, I generally want all of my rational exponents turned into radicals and then simplified from there. So I'll turn this back into a radical and I will simplify it. Believe it or not, this is not simplified all the way. So what I need to do is turn x to the 4th into x to the 3rd times x to the 1st. And I'm choosing that breakdown because an index of 3 and an exponent of 3 are going to cancel out. So 4 turns into 3 plus 1. Remember our rule of if you have a multiplication, add the exponents. And now we can split up both radical terms. This is an exponent of 1. You don't really need to write that there though, so I won't. So now I have the cube root of x cubed. Well, that's just x times the cube root of x. And that's simplified all the way. So anytime you have like the square root of x squared, well, that's just x. Or the 5th root of y to the 5th, well, that's just y. Anytime the index and the exponent are the same, they are inverses of each other. They cancel each other out. So let's try this one. Let's split them up. I have 3 terms here. They're all to the 4th root, so I'll split them up. The 4th root of 16, that's asking a question, what number multiplies by itself 4 times to get 16? So it's 2 times 2 times 2 times 2. That answer is 2. The 4th root of x to the 5th, well, I'm going to break that x to the 5th up like this. And the 4th root of y to the 4th is just y. So I've got 2 and a y, so I'll put those in the front. I've got the 4th root of x to the 4th times the 4th root of x to the 1st. So it's 2y times x, the 4th root of x to the 4th is just x, times the 4th root of x. Can't simplify that. So your final answer, and you want to put your numbers first, and then the letters in alphabetical order. So 2xy times the 4th root of x. And that's finished. Now before I go any further, it's probably also worth noting that at this stage you can also turn this, of course, into, I forgot to do this, the square root, or rather x squared times x to the 1st, which is the square root of x squared times the square root of x. Well, the square root of x squared I just said is x, so that's x, I'll write it down here, times the square root of x. And that's simplified all the way. And I'm glad I caught that because it's actually going to help me as I talk a little bit more about another option here. There's another option for a lot of these problems. I've said this many times in my first video. If I wanted to take x to the 3 over 2, I can actually do it a different way. I can take x to the 3 over 2 and break that up into x to the, and then just divide them. So think about this in terms of a mixed number. 3 over 2 is actually 1 and a half. 1 plus a half is 3 over 2. So now I have x to the first times x to the 1/2 power. Well, x to the 1/2 power is the square root of x. So you see that those answers match up. Let me do this one the same way. Let me get some space here. So I've got options here. Let me show you this option. And let's see, I'm going to go back to my original. So, well, it's actually right here. So I've got x to the 4/3. Well, if I divide 4 over 3, I get 1 and a third. So that's x to the first times the cube root of x. So you might like that method better. You get the same answer. I guess I should have mentioned that at the onset, but I'm glad I caught that. So that brings me back to this level. Right here, let me insert a page. And you can do this one a different way too. You can say, okay, I've got my whole radicand raised to the index of 4, so that's raised to the 1/4 power. And we saw in my first video that if you have parentheses to a power, it needs to be distributed, so that's going to be 16 to the 4th times x to the, remember what you do here, you multiply those two, 5 over 4 times y to the 4 over 4. So this is 16 to the 1/4 is 2, x to the 5 over 4. Whenever it's an improper fraction like that, just divide them. You get 1 and a 4th. And then this one, 4 over 4, is just 1. So we'll continue. I've got 2 x to the first, y to the first, times x to the 1/4, which is the 4th root. And that's the same answer that I got the other way, which is, maybe I didn't finish it. Well, anyway, it is the same thing. I think I did finish it actually, I just maybe separated it accidentally. Yeah, here it is. So let me zoom out and show you that. Same answer both ways. Right here. So a lot of times you have options. You know, it's up to you what option you like. In my opinion, it's helpful to learn everything, so you have the ability to kind of sort of switch back and forth from the different methods. But let's get back into it here. I'll try to present some options for you for this one. Let's see what we can do. So I've got a power to a power. Remember, you multiply these, so we have x to the 8 over 15. So this is the 15th root of x to the 8th. And that actually can't be simplified, so I'm done. Next one, I've got a fraction over a fraction. So you have a couple options here. I'll probably just do, I'll probably just do subtraction, right? Remember our division rule, you keep the base and you go 3/4 minus 5 over 6. To subtract fractions, clearly you need common denominators, so let's turn those denominators into 12. So to get 4 into 12, I multiplied by 3, so do the same to the top. 6 times 2 to get 12, so 5 times 2 to get 10. 9 minus 1 is -1 over 12. So this is -1 over 12. Remember, our negative exponent rules means that that actually gets turned into the bottom. If you have a negative exponent, it moves the whole term to the denominator. It becomes positive. So this one's 1 over the 12th root of x. And we're going to rationalize that in a little bit, but I'm going to come back to that rule a little bit later. because that's actually something that we're going to want to simplify further, but we'll come back to that. I don't want to sort of make the problem a little bit murkier than it is. But anyway, we have the fifth root of 6x to the 20th power. All right, so we have, let's see, a couple different options here. We can do, for this one, I'll show you both. Let's do the fifth root of, and remember this rule, you have the 20 and you kind of have to distribute it into both terms. So 6 to the 20 times x to the 20. Break those up. So you get the fifth root of 6 to the 20 times the fifth root of x to the 20. Well, the fifth root of 6 to the 20 is, if you think about it, it's actually the fifth root of 20 can be broken down like this: 6 to the fifth times 6 to the fifth times 6 to the fifth times 6 to the fifth. Because the rule is you just add these exponents. 5 plus 5 plus 5 plus 5 is 20. Times, got distracted there. Times the fifth root of x to the 20. Well, that's x to the fifth, 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 and fifth. Same deal. And the reason I'm making them all fifths is because now I can split them all up. So I would do this for all. I'm not going to do this, but I'm not going to actually write them all out. But this is what you would do. And each of them is just 6. So this is 6. This is 6, and this is 6. So each one of these just simplifies down to 6, because it's the fifth root of 6 to the fifth. Similarly, over here, each one of these is just x. So at the end of it, you have 6 to the fourth times x to the fourth. And that would be it. Now, whatever 6 to the fourth is, it's a big number. I'm not going to figure it out right now. Maybe I will, actually. 6 to the fourth is 1296. So that would probably be a better answer. 1296 x to the fourth. Now, if you didn't like that method, try this method. Watch this. You might like this better. So let's convert this rational expression, this radical expression into a rational exponent. So remember, the index is the bottom number, and the numerator is this exponent right here. So it's actually now just quantity 6x raised to the fourth power. 20 over 5 is 4. And the rule here is you take that exponent and you move it into both terms. So we have 6 to the fourth, x to the fourth. And what do you know? It's exactly the same. All right, let's rationalize. I told you we had to come back to this. This was one of those scenarios where we have radicals in the denominator. We can't leave those like that. So we're going to multiply top and bottom by radical x. So that leaves us with the square root of x over just x. And that's better. Right? One of our sort of cardinal rules is you can't leave radicals in the denominator. And the process is called rationalization to get that out of there. All right, let's try this one. We have 2 over the square root of 6. So let's rationalize that. Multiply top and bottom by the square root of 6. So we get 2 root 6 over 6, which is root 6 over 3. The 2 and the 6 simplify. All right, moving on. We have more rationalization to do. We're going to multiply this time not by radical x and not by radical x plus 6, but we're going to multiply radical x minus 6. And this is how we rationalize with binomial denominators. You multiply top and bottom by the opposite of that. And our goal is to get rid of the radical in the denominator. That's your goal. So let's see if this works. We have 9 times the quantity radical x minus 6. And on the bottom, we're going to FOIL. We're going to go first times first, which is x. Take this term times this term, you get x. And we're going to go outside, so negative 6 times radical x. And we get negative 6 radical x. The inside terms, positive 6 radical x. And the last term's negative 36. All right here and here. So let's simplify. In the top, we have 9 radical x minus 54, a little distributive property there. And right here we have something awesome. This cancels with this, leaving us with just x minus 36. And we would be finished. All right, again, the whole goal was to get rid of that radical in the denominator, and it worked. Let's try these two. Some more simplifications here. The square root of 75 is not a perfect, or 75 is not a perfect square, so this answer is not going to be necessarily an integer, but what we can do is think about the factors of 75. So 1 times 75, and 3 times 25, and 5 times 15, right? And we're going to choose this pair because 25 is a perfect square. So we're going to break this down into, we're going to break 75 down into 25 times 3. The square root of 25 is just 5. The square root of 3 we don't know. So in your calculators, if you put this in and you put this in, you'd get the same thing. But this one is what we call simplified radical form. Same thing over here, or this time we have a cube root of 40. And the cube root of 40 is not an integer, but we can break 40 down into its factors. 1 times 40, 2 times 20, 4 times 10, 5 times 8. And I'm looking for not a perfect square this time, but a perfect cube. And I see a perfect cube right there. 8 is a perfect cube. So I'm going to break 40 down into the cube root of 8 times 5. Split them up. And anytime you split up, you have to take this 3 and write it twice. So the cube root of 8 is 2, because 2 times 2 times 2 is 8. And the cube root of 5 we don't know. So that's a simplified version of this. Moving on, let's get some more practice here. Again, you have a lot of different options for these. Running about 20 minutes here, so I might not show you both options for all of these because I want to kind of get through them, but this would be a really good time to pause, try this, and see if you can figure it out yourself. So I'm going to go the cube root of 125 times the cube root of w to the 6th times the cube root of y to the 3rd times the cube root of z to the 4th. So the cube root of 125 is 5, because 5 times 5 times 5 is 125. The cube root of w to the 6th is w squared. Right, that's how that works, right? If 6 is in here and 3 is out here, then it simplifies to just w squared. And if you wanted to use your fraction method, you can do that. This actually simplifies to 6 over w to the 6 over 3, so that's where we get the 2 from. This is just y, the cube root of y to the 3rd is just y, and this is going to be z cube root of z. And you want to put all these in the right order, x, y, z, w, x, y, z. So I think it's actually fine. Alphabetical order is what you're looking for there. There you go. Number 2, extra practice number 2. All right, so here we have a power affecting everything that's inside of it. So it's going to get multiplied, so it's 25 to the 1/2, x to the 2 over 14. Well, 2 over 14 is just 1 over 7, so maybe I'll just write it as 1 over 7. And y to the negative 2 over 2, that's just negative 1, so I'll write it as that. So we have the square root of 25, that's just 5. We have the 7th root of x and then we have y to the negative 1. Well, that brings the y term down to the bottom, and that would be finished. Again, once these problems pop up, I'm going really fast here. I want you to get some extra practice. Pause it and try it. Two methods here. I'll show you both. We'll go the fourth root of x to the 17th. That breaks up into 17 breaks up into 4 plus 4 plus 4 plus 4 plus 1. So this is just x, this is just x, 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 and then the fourth root of x. So it's 4 x's on the outside, which is x to the fourth, times the fourth root of x. Or you can go this route. You might like this better. Let's do in your head 17 divided by 4. So it's 4.25. It's 4 and a fourth. So 17 over 4 simplifies to 4 and a fourth. 4 plus 1/4 is 17 over 4. So it's x to the fourth times the fourth root of x. Same answer. Number 4. Alright, so let's see if we can take this and distribute it inside, and take this and distribute it inside. So we get x to the first, 2 times a half is 1, times y to the 1/2, times x to the negative 2, times y to the negative 6 over 4. Negative 6 over 4 is negative 3 over 2. Alright, so this simplifies x square root of y. Well, I'll leave it as y to the 1/2 for a second. I can do a couple things here, but let's take the negative terms and move them to the bottom. Let's do that right now. I won't change anything else but those negative terms.
Please come down.
Sorry about that announcement. So we have these negative terms going down to the bottom, and their exponents are turning positive. So now we have, let's see, x over x squared. Well, that's just 1 over x. This simplifies to just 1 over x. Y to the 1/2 over y to the 3/2, that's 1/2 minus 3 over 2. That's just negative 2. Negative 2 over 2, sorry. Which is just negative 1. So it's y to the negative 1. But that gets moved into the bottom and becomes y to the positive 1. So the 1 is the placeholder right there. So that's your answer right there. If you didn't like that method, which maybe you didn't, it's a little bit clunky, maybe we can do something different. Let's try this. There are a couple different options here. Let's do this. Let's try to I still like this. I like x to the first, y to the 1/2, x to the negative 2, y to the negative 3 over 2. But now let's simply just add these exponents. So you take x and you add the yellows because they're the exponents on the x's. 1 plus negative 2 is negative 1 times y, and then we're going to add these exponents. 1/2 plus negative 3/2 is also negative 1. So that simplifies down into this. You get the same thing. Number 5, pause it, give it a shot. I've got 2 methods here. I'll show you both. I'm going to, let's see, well, maybe I'll just show you one. When I notice, here's a little tip for you. When I notice that my index and my exponent are sort of divisible, in other words, 14 divided by 7 is nice and neat, it's a 2, I'm going to make that simplification right now. Because really, if you think about what this is, 14 over 7 is the fractional exponent conversion. This whole thing turns into this. That's one of the first rules I taught you in this video. What's 14 over 7? It's 2. Awesome. So now we have a FOIL, right? We have this thing times itself. Right, that's what it means to square something, is to make 2 copies of it and multiply them. So now we're just going to FOIL 4x squared plus 10xy plus 10xy plus 25y squared. So 4x squared plus 20xy plus 25y squared. And that would be the finished answer. Almost finished here. We have 3 over square root of x minus 5, so we're going to want to rationalize that, multiply it by the square root of x plus 5. Remember, this is called rationalization, and the goal of this is to simply get rid of the radical in the denominator. So I'm just going to change this sign. So I get 3 radical x plus 15. There's a distributive property there. And here I'm going to FOIL. So I go first times first, I get x. I go outside, which is positive 5 radical x, inside, negative 5 radical x, and last, which is negative 25. And the whole point of this rationalization is to get rid of those terms. So I get 3 radical x plus 15 divided by x minus 25. And that's it. The last one. 27. So here, instead of just immediately going into, rationalizing, getting rid of that radical in the denominator, I'm going to probably start by looking at this radical 27 and understanding that it can be simplified. Radical 27 turns into 3 root 3. And here's how. The factors of 27 multiplies, or excuse me, 9 times 3 multiplies to get 27. So if you split that up, you get the square root of 9, which is 3, times the square root of 3, which of course is not something you can simplify. So I'll do that first. So I haven't done anything to the denominator yet. So I'm ready to work with that. So maybe I'll bring it down here and we'll start fresh. I'm going to multiply top and bottom by 1 plus root 3, 1 plus root 3. So that leaves me with, let's see, FOIL on top and bottom. No variables though, so it's not too difficult. First times first is 2. Outside is 2 root 3. Inside is 3 root 3. And last is 3 times 3. Now where did I get that times 3 from? Well, if you think about it, the last terms both have radical 3 in them. Radical 3 times radical 3 is just 3. And the other 3 is just sitting there right there. Okay, so that's our numerator. Denominator is first times first. Outside is plus radical 3. Inside is minus radical 3. And last is negative 3. Negative radical 3 times positive radical 3 is just minus 3. No radical. Alright, so let's simplify. In the top we have 3 times 3 is 9. 9 plus 2 is 11. Plus these two things, that's just 5 radical 3. Make sure not to put radical 6 or anything. And the denominator is awesome because the radicals disappear and we're just left with 1 minus 3, which is negative 2. Now if these numbers here, here, and here can simplify, you would do it at this stage. They don't in this case, so I'm done. There you go. 30 minutes, a lot of stuff there, but I started by saying that this was the advanced video, so hopefully you got a lot out of that. There were tons of examples, and it all comes down to just knowing your rules. If you know your rules, life is good. If you don't know your rules, then these problems become really, really tough really, really quickly. So there you go, 2 videos on exponent rules. Thanks for watching. Make sure you subscribe, and I will see you in the next one.